Hello everyone. So let's start with the session. So today we are going to solve some problems where we will construct a DFA. But before that, there's some prerequisite that you need to know. So let's start with the prerequisites. And first one is alphabets. What are alphabets in automata theory? Alphabets are nothing but a finite set of symbols that will be represented using sigma, and these alphabets are used to construct strings, which is the next one, next notation. And strings are nothing but a finite sequence of symbols, and these symbols are constructed using the alphabets, or the string is constructed using the alphabet. And this string, the set of these strings is a language. Okay, so in a language, these strings will be used, and this set of strings are going to be created using the alphabet. So the set of strings is built over an alphabet. So it can include all the possible valid strings that can be formed using the alphabets given. And so these three terms get together and it becomes a language. So these are very important terms. First is alphabet. Second is the string, which is the set of symbols, and using the strings language will be created, or using the valid strings language will be created. Next term is empty string, which will be denoted as epsilon, and epsilon is nothing but a string which is an empty string which doesn't have any symbol, so it's like a vacant place over there, or null string that we can call it. The example is epsilon itself. It's a null string, so there is only one valid example for this. So next is state. Now state will be a specific condition or situation for that automaton at the given time. Now let's consider a vending machine. Let's say in a vending machine there might be different stages or states. First state is um, it will be at a state where it cannot. Okay, let's take an example of a food ordering machine, where in food ordering machine there will be a screen, and in that screen you'll be able to see um, a home page maybe, and in that home page maybe a welcome text is shown to you, right? Welcome, hi, and would you like to order some food? That might be some text will be visible, and there will be a button which will be redirecting you to the menu page, right? When you click on that button, the page will be changed, right? So the next page will be a menu page, and in that menu page there will be a listing of items, different types of items that you can order from. And the change of these pages are nothing but change of state, right? And the click on that button will be the input that you have given to the machine, right? So these pages are nothing but states, and the change happening because of the input that you have provided is called as transition, that is happening from one stage to the next stage, right? So this is a state and transition. Now let's talk about how DFA will be defined. Okay, so DFA will be defined using five tuples. So, for example, if we consider M as a machine, that machine will be defined using these tuples. Now, what are these tuples? First is Q. Q will be the set of strings, the set of states that are present in the machine. So let's say in a food ordering machine, there might be multiple pages. First will be welcome page, second will be a menu page, third will be a payment page, right? And these three will be three different states, right? So these set of states will be represented as represented as Q. And next thing is sigma, which we already saw here. It's a set of alphabets, a finite number of alphabets which are present in that current DFA or any finite automata. This will be a transition function delta. That means how many transitions are happening in that automata. Q naught will be the first state or the starting state, and F will be the final state, or we also call it as except state, right? Now, there are some conditions in DFA, or in definition of DFA, this condition should be true in order to get that DFA as a correct one. So first is a DFA processes input string symbol by symbol. So if an input string is given to you, it will process that input string one at a time, um, or one single symbol at a time. So first symbol that will be processed here will be one, then zero, then next one, then the next zero, then two, three, and four, so on, right? So that is the first uh, condition. That means every input will be processed symbol by symbol. Okay. The second condition is for every input symbol, there is exactly one path from the current state to the next state. That means for a single input, this one is nothing but a input, right? So for a single input, there will be only one transition. The state change will be happening only once for a single input. Okay. So let's say for two, um, the transition given in the automata, DFA is changing from if the current state is product page and two input is changing that state to other different state, which might be a payment page, right? So that transition only will happen once. That means only one transition is allowed for a single input symbol, right? So this is the second one. Third one is DFA does not accept the null move. That means if you don't provide a input, any input, it cannot change state, right? That means if you do not click a button here, so it will not change the screen automatically to the menu page, right? So you should click that button or you should give the input, then only the state will be changed, right? So that's the third condition. Fourth one is DFA can contain multiple final states, and that means for accepting a string, there can be multiple final states present where we can say that, yeah, the string is acceptable or string is accepted. So accepting a string is nothing but you're having a valid input for that machine. So valid inputs can be multiple, right? Because for a machine, let's say for we're taking example of vending machine. If a vending machine is there and there are multiple different types of snacks present in the machine, when you put a coin inside that vending machine, that will be your first input, right? And for that input, you'll get um, a snack that you'll maybe there will be a maybe keyboard here, which will contain the number at which the snack is present in the sequence, right? And that button will trigger that snack to get out. So when you click on that button, that will be your second input, right? So putting the coin and pressing that button will be the sequence of inputs or a sequence of input string that you're providing to the machine, right? So these two inputs will be essential to get that snack, right? But that doesn't mean if you give the coin and put another button, and that will not an accepted state because it can give you the snack. That means it is an accepted state, right? So for that this machine, the essential state will be first putting a coin and pressing a button, right? Which can be any button. So any input you can give afterwards. So the sequence should be there, but in order to get accepted, there can be multiple final states, right? But this also doesn't mean that you can give any input because if you only give coins after coins, let's say you have given three different coins at a single time, it will not give you any snacks, right? Because you need to push a button, but you're not pushing it. That is a invalid input. So that will not go into final state. That will be a invalid input string that you're provided. So that is a different case than this one. So this was the fourth one, which says DFA can contain multiple final state. So with that being said, let's go and solve our first DFA problem. So the first problem says design a DFA which accepts the strings with an even number of zeros and followed by single one, right? Now the thing is, there is one more condition for DFA, which is DFAs are memoryless. That means DFA cannot store data. So when you create a DFA, there is no memory space to store it. Okay, so how can you count number of zeros? Are they even or not? And if it is not possible, it's not possible to construct a DFA, right? Is it? No. Here, we're not going to directly count the number of zeros. We're actually logically see if it is having an even number of zeros or not. How? Let's see. If this is our first, let's say, starting state, and this can be, let's say, Q0 or Q naught, we see. Q naught, this will be a starting state. And from starting state, there will be a final state where um, the input will be called as accepted. So final state will be, let's say I'll call it as final directly or F. F is enough, or is it possible to write? Okay, it's a final state, right? So in order to get here, what you need to do is there are two conditions. First condition is first condition is you should have even number of zeros, right? And the second condition is that even number of zeros should followed by a one, right? A single one. So these two conditions should met in order to get the output, right? So you need to check first, are there even number of zeros present or not, right? So if you're in the start state, that means you haven't gone through the input yet, right? So for that, we'll also take a example input string, and as it only contains 0 and 1, so I'm going to take 1 0 0 1, and it says even number of zeros. So these are even number of 0 and followed by 1. There are two ones, but still, let's take only 4. So this is a example string in example input, and on this we'll construct our DFA. So DFA says in order to get even number 0, you need to count those, but you cannot count number in DFA. So you'll logically count it. How? In a first state, you haven't gone through any of the input yet. So the count of number of 0 is 0. That is an even number, right? When you change the state, let's say you're in this state. This is in state, we'll call it as Q1. And here, all the number of 0 will be odd. Okay, why? Because whenever Q naught encounters a 0 or first 0, it will go to Q1. Okay, and whenever it goes to Q1, the the state or the input will be 0. Whenever it encounters 0, it will go to the Q1, right? Now, the thing is, what happens when 0 becomes even? That means whenever Q1 gets a 0, it will also give the current state. It will change the current state to Q1 Q0 again, because now the um, now the zeros are even, right? If it is an odd number of zeros, Q1 will change state to, sorry, Q0 will go to Q1, and whenever Q1 is there and it encounters 0, it will go back to Q0, right? Now for this string, let's say it encounters 1. Currently we haven't given this transition yet, but it will be there because DFA should have every transition possible. Second is 0. Whenever Q0 will encounter 0, it will go to Q0 will go to Q1 state. Now this is the current state. Now it encounters again a 0, so it will come back to Q0. That means this will now be our current state. And when it encounters 1, now for 1, we need to check for 1 what should happen, right? Because the second condition is it should be followed by 1. So whenever in Q0, because it should be first condition should also met, right? So first condition is meeting whenever the current state is Q0, right? So in Q0, whenever a 1 is occurring, so whenever a 1 is there, it will go to the final state directly. Okay, why? Because first condition is also passing and second is also passing, and that is, this final is nothing but our accepting state, right? So that is will be represented as double circles. And here still it's not a DFA because every state should consider all the input symbol. So for Q0 we have considered 0 as the input, um, which will be transition to Q1 state. But okay, for 1 also we have checked, but for Q1 there is um, no account for 1 as the input. So for that we'll take a input 1 and redirect that 1 to Q1 itself again, right? Because whatever the intermediate numbers, we don't need to check for them. So whenever a 1 is occurring, Q1 will also redirect to itself, and whenever 1 is occurring in Q0, that will go to final state. So whenever we are in Q1 states, the count of 0 will be odd. Whenever we are in Q0 state, the count of 0 will be 1, right? And when it's in the final state, right? It's in the final state and it gets an input of 1 or 0. That means that the string is not over yet, right? If this 101 is actually 1010, right? That is not mm, a valid string, right? Because it should have an even number of zeros followed by single one. Is it a valid string? It is a valid string because it is still followed by one. It's the condition doesn't mean that the last input symbol should be one. It just says all the even number of zero but followed by one, right? So it is correct. Even though third zero is there, this doesn't mean that the count of zero will become odd now. No, it's checking the count of zero before the condition where it is one now, right? So this is how the first problem will be solved. For this one, let's take these things from this. First is um, Q, which is the set of states present in this DFA, right? So in this DFA, what are the different states present? Set of states. First is Q0, second is Q1, and last is final. Or we can call it as Q3 also. If we don't want to name it as final, I'll rename it as Q3. So three different states are, sorry, should call it as Q2 instead of Q3. Okay, so these are set of states present. So Q equals to this. Second is alphabet. What are the alphabets present here? So the alphabets present here are, let me take sigma here. Sigma will be representing alphabets. So alphabets present here is 0 and 1 only because that's all the symbols that are present in the input string, right? And the third is transition function. Transition function will be represented as delta, and it will have all the transitions present, right? So we can maybe create a table for, let's say, 0 and 1 transition. And in that 0 and 1 transition, let's say for Q0, what are the transitions that are happening? For Q1, what are the transitions that are happening? And for Q3, right? So in the table, for Q0, uh, in in Q0 state and for input 0, the transition happening here is to Q1, right? So it should go to Q1, and for 1, it is going to Q2, right? So that is the transition happening here. So I'm gonna write it like this. So it will look like a table. So in Q1, the transition happening is 0, for the 0 input is going back to the Q0, right? And for the 1 input is, it is still being in the same state, so it will be Q1. For Q3, now there is nothing happening here, so we don't have to write anything, or we can call it as epsilon also, because there is no input symbol. That is the last state, final state. And if there is an input, we might do one thing. We can just redirect every input to the same state as well. So that is also a valid DFA. So for Q2, we'll redirect every input symbol to the same one because that is still be accepted, right? So that this is the transition function. And next thing is Q0. Uh, Q0 will be Q0 itself because that's the name of our star symbol as well, right? And the final state, which is F, will be our Q2, which will be represented as this double circles. And currently, it's only single final state is there, but there can be multiple final states. So this is the first problem that we solved. Let's go to the second problem, which is DFA for strings starting with 1 and ending with 0. So a string that starts with 1 and ends with 0, that's what we need to create. Now, let's create a starting state. and let's call it as Q0. Now we know that the starting input should be 1, right? So if there's an input which is not 1 or which is 0 directly, that means it's a string is invalid itself because it's not starting with 1, right? So directly we can um, change the state to a state which will be not accepted by our um, DFA, right? Now that state we might call it as a dead state, because dead state will be a state where if if the current state is a dead state, that means all the input that are processed on dead state will be there only, right? So in dead state, if it encounters 0, if it encounters 0 or 1, everything will stay here. Okay, so for 0 and 1, dead state will be in the same state, and the transition will happen in the same state. So it's not a final state also. So at the end, the input will be rejected, right? Now that is first condition that we handle, which is for starting with 1, right? Now we should handle ending with 0 as well. So if we create the next state, now this Q0 state was there for 1, right? So 1 was the input, starting with 0 actually. 0 was the input. If 0 is there, it is already rejected. We need to create a transition for 1 as well, right? So Q1 will be the next state, and in that state, the transition of 1 is happening, right? Which is a valid transition as per the conditions, right? So this is the first transition which is happening for 1. Now in Q1, it will go to the final state if it's a 0, because if it's the last number, it can be 0. If still it's not the last one, we need to check that condition in the final one. So here there should be a final state. So I'll call it as maybe Q2, and Q2 is a final state. So what we are going to do is, let's make a double circle so that we'll know that it's a final state. Now here from Q1, it will go to Q2 if the input symbol is 0, right? So if it is ending at 0, if Q1 encounters 1 itself again, then it should go to the same, I mean, it should remain in the same state, because for any intermediate input symbols, there is no need to check anything because there is no condition given here. For 1, so we can be in the same state, right? Q1 can be in the same state, right? But in the Q2, if we are in the Q2 and the current state is, um, so current input string is still processing, so we don't know that it's the last symbol or not, right? So if it is there after 0 input is processed and it gets another input which is 1. If it is 0, that is fine. It can be in the same state, right? So if it is 0, it's very well that it stays in the same state, which is final, because we need that 0. But what if it's not in 0, it's a 1? We need to take account for that. So if it is 1, we can do one thing. We can pass it to Q1, right? So if it is 1, it will go to Q1, because Q1 is not a final state. So it will, if it 1 is encountered at the last, still it will at the end will be in the Q1 state. So it will be rejected, right? Because Q2 is only final state present here. For same, we can create these tuples as well. You can see and create the tuples. We'll just go to the next problem directly. Next problem is DFA machine that accept a string with even number of zeros and even number of ones. And we know that DFA cannot count the number of things, or cannot count or store memory, right? So having even number of zeros and even number of ones is not possible at all. But why? What if we don't even need to count? We can check everything with only states, right? So there can be 4 conditions. First condition is if first condition is if there are two numbers or two alphabets will be there, 0 and 1. If the count of 0 is count of 0 is even, and count of 1 is also even. That means it's the accept state, right? Or it's a final state. It will be in the final state, right? If it's the second condition will be if 0 is even but 1 will be odd, right? That can be a condition, and it's not a accept condition as the constraints are. It both should be even, right? Third condition can be 0 is odd and 1 is even. So that is the third condition. The fourth condition can be 0 is odd, also 1 is odd, both are odd. That is not also the condition that we are requiring. So in these three conditions, the input string will be rejected, right? Only one accept state is there. So can we directly create four different states for four different conditions? Right? We can. This will be Q0, and there can be four different states. Let's say these are the four different states: Q0, Q1, Q2, and Q3. Now, how can we redirect, or how can this DFA will change states whenever a specific symbol is encountered, right? Now, Q0 will be the start symbol, right? So that is how we can represent Q0. So it's a start symbol. So remember, we need to check the number of zeros and one, right? So in 0, when input is just started, so there is no symbol is processed, right? So there is no 0 or no 1. So eventually no means 0 only, right? So number of zeros will be 0 and number of ones is also 0. That means the count is even for both of them, right? So for the start symbol, the count is 0, and if at the end the string processed in the same state Q0, it will be a accepted string, right? So Q0 becomes the final state itself, right? So Q0 can be called as a final state because the number of even um, 0 and 1 will be there, right? So that is a final state. Now, for three different states, we can consider these three states. Let's say Q0 will contain even number of 0 and even number of 1. Whenever we encounter a 0, that means now, um, if I take an example here, um, let's say 0, the count of 0 is 0 because no string is processed, and count of 1 is also 0 because no string is processed. Okay, so currently, our current state will be Q0. Okay, I'm gonna like create a rectangle on it. So this is our current string, and it's because all the zeros and one are having zero count. After that, if we encounter a zero in this state, so it should go to a different state. Let's say from this to this, it's going right now. This state change is happening on 0 because 0 is the one which is processed here. So number of zeros will be 1 now, right? So the current state is changed from this. Okay, this should not be connected. Okay, now it's fine. So Q1 is the current state now. So Q1 is having 0 as 1, which is an odd number, and 1 is 0, which is an even. So it's a third condition where 0 is odd and 1 is even. So Q1 will have key the current state will be Q1 whenever 0 is odd and 1 is even. Okay. Now what will happen when both of them are odd? Okay, that means if one is processed. So if in Q1, one is being processed, I'll do one thing. I'll remove the current state here for a moment. If Q1 is one is processed, we can change the state to Q3 maybe because the current count will be 1 and 1, right? So that means Q3 will have odd number of zeros and odd number of 1 as well. So current state is Q3 and 1 is processed here. So this will be the fourth state. From fourth state, what if we only missed the second state, right? Second condition, which is even number of 0 and odd number of ones. So here, Um, in order to get even number of 0, we need to process 0, right? So it will become 2. So in order to process 0, whenever this state is processing 0, it will go to the next state, right? So here in this Q2, we are currently here in the Q2, and it's processing um, the count of 0 is even and count of 1 is odd, right? What if in Q2 we encounter another 1? So now it will become even again, right? So that means again it should go to Q0, right? Because Q0 is for even numbers. So that means again the control will go to Q0 whenever 1 is encountered, right? So that is a cycle. But in order to get a DFA, correct DFA, all states should consider all the input symbols. So for Q0, it have considered 0. That is correct. But it didn't consider the 1 input, right? For 1 input, what will happen when Q0 gets 1? So the uh, number of ones will become plus 1, which will become from even, it will go to odd, right? So if 0 is even and 1 is odd, which state it should be? We can say here. Okay, I'll change the order because that is kind of confusing. So it's a Q2 state, right? The first one was Q1 state or Q0 state. This one was Q1 state. This one was Q3 state, right? Now, whenever Q0 encounters a 0, it will become 0 will be even and 1 will be odd. So 0 even, 1 odd is the Q2 state, so it will go to Q2, right? So this transition will happen for 1. So we can call it as, okay, this is happening for 1, right? From 0, Q0, it's going to Q2 for a 1 input, right? So for Q0 state, all the inputs are processed. Now let's go to Q1. In Q1, the number of zeros will be odd and number of 1 will be even, and it has considered for 1, um, which is been considered. So if it should consider for 0, if in odd 0 a 1 is added, that means 0 will become even, right? So for even 0 and even 1, the state should be Q0. So the transition of Q1 for 0th input will be Q0, right? So that is how it will flow. So for Q1, we consider everything. Let's for consider for Q3. For Q3, the number of odd, uh, the number of 0 and 1 will be odd. Both will be odd. So we need to consider for 1 because 0 we already considered. If we change the number of 1, it will become odd and even. And odd and even is the Q1 state. So from Q2, the state change should go to Q1 and the input will be 1, right? And so Q3 is also done. For Q2, we have considered 1 only, and when we see Q2 is even and odd. So we need to consider for 0. If even becomes in even 1 is added, it will become odd. So 0 will be odd and 1 will be also odd. So odd will be the third state. So sorry, the fourth state Q3. So the transition will happen from Q2 to Q3, right? And the input processed here is 0, right? So that is the whole DFA for our this problem where DFA machine accepts a string with even number of 0 and even number of 1, right? So this is the DFA which will which is having this condition fulfilled. You can create 5 tuples here and check what are the 5 tuples. Maybe we can do it for this problem as well, right? Maybe I'll copy here from here to this here. Okay. So what we know, what are the different states here? Q0, Q1, Q2, and Q3, right? So Q will be these 4 states, and input will be 0 and 1. Alphabets will be 0 and 1, same. That is correct. We missed one thing, which is transition function. So transition function will consider what are the different types of transitions that are happening, right? So here transitions are happening. I'm gonna copy this much. Okay, just a single, so we don't need this equal to. So here transition is happening for two symbols, but the states are this time four. So there will be Q0, Q2, Q3 will be there, right? Now let's see for Q0. Q0 state for 0 input, it's going to Q1, that is correct. For 1 input, it is going to Q2, that is also correct. For Q1, the 0 input transition is Q0, that is correct here. And for Q1, the 1's transition is to Q3, which will be this. For Q2, the transition of 0 is to Q3, so this is correct here. And the transition from Q2 for input 1 is Q0, so this will be Q0. And from Q3, the 0 input transition is Q2, so this will be Q2, and the 1 input transition is Q1, right? So this is the transition table, right? And the start symbol is going to be Q0 and the final state. Now here, um, where all the input is getting accepted, where the string is getting accepted in Q0, and we also shown it as a double circles. That means it's a accepting string. And yeah, that is all five tuples, which is created using the DFA. And let's go to the last problem that we have today. Now construct a DFA which accepts a set of strings over AB. So AB will be the alphabets used in the strings, and it should not contain substring AAB and begins with A. So here again two conditions are there. First is it should begin with A, and second is it should not uh, contain AAB. Okay, so these two conditions that we need to check. Um, let's create a state, a starting state Q0. From this Q0, we need to go to the final state, but we should consider uh, consider a path where AAB will not be found. AAB substring will not be there. So as we know, the alphabets are only A and B. So there are two possibilities for Q0. It can have A as an input, or it can have B as an input, right? And as the first condition says, it should begin with A, right? So if it is A, then only it should be processed. If it is B, then it should not be processed. So that means the string should be rejected, right? So if I change the direction here to this, and the state is going to be changed. So where this going to be, it's going to be a state which will be called as a dead state. That means from this dead state, all the state input will be rejected. Even though in dead state you get an input, that input will be redirected to the same dead state. So only the possible inputs are A and B. So both will be redirected to the same dead state, right? So from the dead state, you cannot go for back to the starting state, right? So that is essentially for rejecting a string, right? If it is B, it will be directly rejected. If it is A, that means it is possible to get a correct string, right? So if it is A, we also need to check the second condition. If it should not be AAB, right? If it is AAB, then it should be rejected, right? So here, let's say in the next state, which is Q1, in the next state, it can encounter A and B both. But if it's encountering A again, that means there is a possibility that A, B could occur, right? So it can go to Q2, the next state, which can check for next possibility of B. Is B there or not, right? So from Q1, it can go to Q2 if A symbol is there. But what if in Q1 we got B symbol? That means it's not AB, right? It's it is something else. So for that, we can directly get it to the final state. Let's say this is the final state, and I'll call it as Q3 maybe. Okay. So from Q1, it directly goes to Q3 if it encounters 1, sorry, B. That means from starting state, we are getting A and B. So which will be an accepting state. So for accepting our final state, we will write it as double circles, right? Q3 is there. Now for Q1, both the inputs are being processed. For Q2, let's say, if it is encountering B, that means it's an invalid substring that we actually should eliminate. If it is encountering that B, it should be rejected, right? So it should be rejected here. So this will be for B, right? If it is encountering B, it should go to the dead state directly, right? So it should be rejected. So that's been done. From Q2, it can be A again. That means if it is A, still there is a possibility of having AB, right? Because A is already processed and second A is encountered. So there can be other A's possible. So if there's a A, this Q2 will redirect it, redirect that A. I mean, the state change will happen and it will change the state to itself, right? So it will stay in the same state basically. So for A, it will be in the same state, right? So for Q2, we processed A and B as well. Done. So what if after going to final state, the string still is in process, right? So string is not finished. So from Q3 or the final state, if it is encountering A again, so that means there is a possibility of um, having AAB in the next substring, right? So it also needs to go to Q1 again because A is processed. First A is processed, second A can be processed in Q1, which will go to Q2. And if it is B again, it will go to dead state, right? So A is processed in Q3. What about B? If it is B, that doesn't mean anything because B can be processed directly because the previous input is B, right? So it cannot create AAB. So the the B will be redirected to Q3 only. Okay. So this will be the final DFA for the fourth problem, which says a string that should not contain AAB as a string, and also it should start from a symbol A, right? We'll also create these 5 tuples for this. Let me copy it and here. So the number of states here are Q0, Q1, Q2, Q3. These are there. A dead state is also there. You can name it Q4 as well. It's fine, but I have named it as dead. But uh, I think Q4 is fine for this, right? So for understanding, I'm just keeping it dead. And sigma, which is alphabets. Alphabets present in this example are A and B. Now these are symbols, actual alphabets. It can be anything that, as we know. So this is fine. Now third is transition function, transition table that we have created. So here um, there are different. There's one more transition happening for a dead state as well. So we are going to add for that as well. But let's start with Q0. From Q0, if it is, so the input will be also different. It is not 0 and 1 now, it is A and B. So for E, A input in Q0 state, it will go to Q1. Got it? From Q0, if it is the B input, it will go to a dead state, go to the dead state. From Q1, if it is having A input, it will go to Q2 state. From Q1, if it is a B input, it will go to Q3 state. Got it? For Q2, if it is A input, it will stay in the same state, which is Q2. If it is a B input, it will go to dead state, right? This is also done. For Q3, it's the final state. If it is having A input, it will go to Q1 to check if it is the substring is repeating or not. If it's a B input, it will stay in the same state, which is Q3. The dead state for both of them, it will stay in the same state, which is the dead state again. So this will be the transition table, right? The starting state will be Q0, the final state will be Q3. Yeah, so this is it for our DFA. You can check for multiple examples as well using this DFA. Is it working or not? And as we have solved it correctly, I'm sure it's going to work. So that's it for now. Thanks.